transaction. Okay. Transaction A, B, sum. Function void display. Display. Okay. A, B, sum. End function. End class. Class error. This is error is nothing but a class name. Extends transaction. Transaction is a parent class. Error is a child class. Constant data C equal to A equal to 0, B equal to 0. End class. Class generator starting now. Transaction trans or TR. You can keep TR also. That handle name. Mailbox hash transaction MBX. Event done. On function new equal to mailbox hash transaction MBX. This dot MBX equal to MBX. See, you are remembering this. No need to remember these things. One for one for one for one circuit. If you write the I mean test bench, remaining all test benches all are same. Okay. See here. This dot MBX equal to MBX end function task run trans equal to new for I equal to for I int I equal to 0 I less than 10 I plus plus began trans randomize mbx dot put trans dollar display gen data sent to driver trans dot display has 20 end implication done. That is nothing but event triggering end task class end class. See interface add interface AAF in driver we will do. In interface we are not giving either inputs or outputs, right? Those things we will give it in a mod port to DRV. With respect to DRV, we will give it to mod port. Okay. Here all are logic. A, B, sum, clock. Okay. DRV input A comma B, input sum comma clock. End interface. Class driver. Virtual add if A VIF. Mailbox has transaction MBX. The transaction data. This is it. Function new. Mailbox has transaction MBX. This dot MBX equal to MBX end function. Task run. Okay. For forever begin MBX dot get data at the rate POSIT AF clock AF dot A equal to data dot A AF dot B equal to data dot B dollar display equal to DRV interface trigger data display end task class will be closed. Now test bench add IF equal to AIF driver equal to DRV generator equal to you are giving all handles here or instances you can call error equal to error event done mailbox hash transaction MBX add DUT AF dot A AF dot B AF dot sum AF dot clock initial begin AF dot clock equal to 0 end always hash 10 AF dot clock equal to negation of AF clock. Initial begin MBX equal to new. ERR equal to new. DRV equal to new of MBX. MBX we are putting in new for DRV so that it will go to DRV. Gen dot MBX. Gen dot trans equal to ERR. DRV dot AF equal to AAF. Done. Gen dot done equal to done. And initial begin fork. Gen dot run. DRV dot run. Join none. Wait done. If wait done is completed, then only it will go to finish. So this is how this is the test bench. See, this is one of the adder circuit. Okay. 112. It is telling undefined module add was okay. Add is not there. Okay. For this one, doubt session. This only we have done right now, right? This one we will copy paste. It's- Yeah, this is only we checked it. This is only we checked it. This is also adder only. Why these adders are not working? Yeah, this working it seems. Again error. This one not even single one is working. Somewhere there is an error. Some minute error is there that I'll rectify it. I'll ensure you. This is different or what? This is also same. Or else simulator problem also might be there sometimes. It cannot hold its work library properly. Okay, okay, this is not happening. Now there is a design and its test bench. Okay. These things are called protocols. Protocols have protocols we will verify. Okay. Those are all
Okay.
those are all codes with the adder. What is the problem? I'll find out and I'll let you know. Okay. So
Okay.
with these protocols, your SV is completed. System Verilog is completely completed. Now you need to go to
Okay.
UVM. If you complete that UVM, then you are ready to go for an interview. Okay.
Okay. UVM. UVM is the new method for verification, na?
Yeah, universal method of verification.
Okay.
That is also same like this only. But what is the difference is I'll explain after that time, not right now. These are called protocols. Okay. Remember, these are called protocols. Here one D flip flop is there. Okay, you know how to create D flip flop. Okay. Remaining designs I don't.
Okay. Okay.
This is always at the passage of
UVM will take how many days?
UVM will take
Hello.
2 to 3 days.
Okay.
This is design. You have to paste it at the side of design. This is design, right? Here you will paste it.
Okay.
This is test bench. You take it. See, this data is D in data, D out data, D in data, D out data. It is matched. Okay, data is matched. Data is matched again. Data is matched. Okay, we will see its test bench.
क्या चादर तो लगा दो जैसे छोटा छोटा सामान
See,
तो जरूरत नहीं पड़ेगी ये सामान हटवाने की जरूरत नहीं पड़ेगी यहाँ कैसे पेंट करेगा वी शेप में तो यहाँ से यहाँ लग जाएगी वो ऐसे करके कर लेगा ठीक है फिर पेंट करना पड़ेगा
see, transaction rand bit D in. Okay, define a random input bit with D out. Define a random output bit D out. Function transaction copy. Copy equal to new. Creating a transaction object. Copy dot D in. This dot D in. Copy dot copy dot input values. Copy dot D out. This dot D out. End function. function void equal to display. Okay, input string tag. We are passing two arguments, input string tag dollar display. Wait a second. Okay, this is, as you know, function void display input string tag display input d in. Okay, d out, d in d out. You are creating at the transaction level. Generator, you are creating transaction tr. You create like this only, transaction tr mailbox hash transaction mbx. Okay, mailbox transaction mbx ref. This is create mailbox to the driver. This is to the mailbox to send to the scoreboard for comparison golden data. Okay,
Okay.
SCO next. Yes, event to send the completion of the scoreboard work. After the completion of the scoreboard work, then only next packet has to be sent. It should not send before that. Int count, event done. Int count, stimulus count. Function new mailbox hash 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 transaction mbx equal to mailbox hash transaction mbx ref. This dot mbx equal to mbx. Initialize the mailbox for the driver. This dot mbx ref equal to mbx ref. Initialize the mailbox for the scoreboard. Transaction transaction new. Okay, create a new, create a create a new transaction object, end function. Now we are coming into run. Repeat count, whatever maybe the count is there, that we need to repeat. Begin assert tr dot randomize else dollar error. Okay, this generator randomization failed. mbx dot put equal to transaction dot put a copy of the transaction into the driver mailbox. Okay, mbx ref dot put equal to tr dot copy, put a copy of the transaction into the scoreboard mailbox. Tr dot display display the transaction information. At the rate SCO next, wait for the scoreboard's completion next signal. End. This is implication operator done. Trigger done even when call stimuli are applied. Okay. End class. Class driver. Transaction tr equal to define transaction object. Okay. Mailbox has transaction mbx create mailbox to the receive data from the generator. virtual DEF, DFF, IF, VF. Okay, this we are making as virtual interface for the DUT in driver function. This is called creating a constructor. In constructor arguments, we are passing mailbox has transaction MBX. This dot MBX equal to MBX. Initialize the mailbox for receiving the data transaction. Task res, task reset. VIF reset equal to 1 tick B1. Repeat after 5 means it waits for 5 clock cycles. At the rate passage of VIF clock only. We will take from test bench to the clock VIF, virtual interface clock. So that virtual interface clock after passage, it will come after 5 passage clock wait. Okay, that's what this repeat means. VIF CS RST equal to 1 tick B0. At the rate passage VIF clock equal to wait one more clock cycle. At the rate delay equal to DRV reset home. Display reset compilation home. Okay. Task run. Forever begin. MBX dot get equal to get transaction. Okay. VA of DN equal to TRDN. This here task we are defining the task. You know how to create a task. And next monitor. Monitor we are defining. Transaction TR mailbox transaction dot MBX creates a mailbox to send the data to square board. Okay, virtual VAF. Wait a second. Sorry. See here transaction TR. Okay. Mailbox hash at the rate mailbox. This is to create send to the scoreboard from the monitor. Okay. From function new. This is called creating a this is initializing the mailbox for sending data to scoreboard. New. This will create a transaction. Here see vr dot d out equal to do it. MBA dot put tr send it to the scoreboard. scoreboard. How scoreboard look like? Transaction we need to define. After that, transaction tref, transaction or tref defines the reference object for the comparison. Okay. Mailbox, mailbox has transaction mbx. Mailbox has transaction mbx rf. This is mailbox reference one. This is mailbox this one. Event sco next. Event signal completion of the scoreboard. Function, see this function initialized for the receiving the data from the driver. Task run, forever begin. Okay. mbx dot get tr, get a transaction from the driver. mbx dot mbx ref dot get trref, get a reference transaction from the generator. tr dot display sco, display the driver's transaction information. Okay. If tr dot dout equal to trref din, this is only the main condition. For this only we have done all this much work. Okay. If tr dot dout equal to trref dot dn, trref t reference dot dn, if these two will become matches, then it is called data matched. Okay. Else data mismatched. Again, we need to go for environment. In environment, what are all the blocks there? Generator, gen, driver, drv, monitor, mon, scoreboard, sco, event next. Mailboxes for transaction mailbox. GD means generated to driver mailbox. Mailbox has transaction. MS means mailbox. MS means monitor to scoreboard. After that, monitor to scoreboard. MB ref means mailbox from MBX ref means mailbox for communication between generator and the scoreboard. Okay. After that, virtual VIF virtual interface DUT function. In this function, what we are doing? Virtual DFF, IF, VIF, GD generated to driver mailbox. This is one. MB, MBX ref. This is reference mailbox for scoreboard. Generator. GD MBX comma MBX ref. Generator, we are initiating the generator. DRB, new GD MBX initiates the driver. Monitor, new MS MBX initialize the monitor. SCO scoreboard, new MBX MS MBX, which means initialized to the scoreboard. This dot VIF. Okay. These are there in the gen dot score next. So that communication will be between scoreboard and this thing. See SCO dot SCO next end function. Task pre-test, DRB reset end test. Task test, fork join, gen dot run, DRB dot run, mon dot run, SEO dot run, join any end task. Okay. Task post test, wait for gen dot done triggered. Okay. Finish end task, here finish. Okay. Run command, pre-test, test, post-test, end end task, end class, module. In module, what we will do? We will define DIF, IF, VIF, create the DUT interface and DIF, DUT, VIF. Okay. DIF, DUT, VIF, instantiate the DUT. Initial begin, VIF dot clock at the rate 0, initial clock signal. Always Hash 10 VIF dot from the test bench only we are creating the clock. See, VIF clock equal to negation of the clock. Toggle the clock for every 10 time units. 20 time 10 time units toggles time period will be 20 nanosecond. Environment ENV initial begin. ENV equal to new VIF. ENV equal to uh, new count. ENV equal to run and this dump files so here if we run this, these are all coming, and if we ep wave, see, ep wave I am taking. See here, this is clock, this is dean. Okay, dean, two clock pulses for every clock. Okay,
Okay.
this is 1 nanosecond, 270 nanosecond. Dean, d out, same after one clock cycle delay it is coming. See, dean equal to d out. Actually our d flip flop uh, as passage of the clock, if we apply clock, then d equal to q, right?
Right.
But it won't happen in real time. See, there is one clock period time. See, this is d in 1. It is happening at the next clock pulse. Practical,
Yes.
this is also simulator. In practical, there will be so much difference. Okay, you will get confused also
Okay.
if I give some scenarios.
Okay.
Do one thing, you prepare this thing, okay, with pen and
Okay.
paper for one test bench. For all test bench system Verilog is same. Only signals will be changing.
Okay.
Signals will be changing. Okay.
Okay.